Imagine this for a moment. You plug a device into the wall. The electricity flows, the screen lights up, everything works perfectly. You never stop to ask why. Why doesn't it explode? Why doesn't it burn? Why does a device built in one country work flawlessly in another? The answer is something most people never think about. International standards, invisible rules, silent agreements, a global language that holds our modern world together. Today, I'm going to tell you the full story, not as a boring list of rules, but as a journey from chaos to cooperation to the system that quietly runs our lives. Let's go back in time. The early days of electricity, the Industrial Revolution. Factories were appearing everywhere. Cities were growing fast. Electricity was a miracle. But it was also dangerous. Every company used its own. Voltage levels, frequencies, cable sizes, safety rules. There was no agreement, no coordination, no global thinking. A machine designed for one city could fail or kill in another. Progress was real, but it was wild and uncontrolled. As systems became larger, the problems multiplied. Fires caused by electrical faults, factory shutdowns, train accidents, equipment destroyed overnight. Engineers began to notice a pattern. The failures were not caused by lack of intelligence. They were caused by lack of consistency. And slowly, a realization emerged. Innovation without rules is not innovation. It's risk. Before organization, before committees, before official documents, there were engineers talking to engineers. They met in workshops, they shared failures, they compared designs, and they began asking simple questions. What if we all used the same voltage? What if safety tests were identical? What if machines could understand each other? These agreements were not called standards yet, but that's exactly what they were. A shared decision to stop repeating the same mistakes. As electricity crossed borders, informal agreements were no longer enough. The world needed structure. The International Electrotechnical Commission, the first global body focused on electrical standards. Its goal: make electricity safe, reliable, and compatible worldwide. After World War II, trust was broken. ISO was created to rebuild cooperation through technical agreement instead of politics. Born from engineers, for engineers, it shaped the future of power systems, communications, and computing. These organizations didn't command authority. They earned it. Here's something most people don't know. A standard is not written quickly. It goes through 1. A technical problem. 2. Expert proposals. 3. Heated debates. 4. Simulations and field tests. 5. Revisions. 6. International voting. Some standards take 10 years or more to finalize. Every word matters. Every requirement is challenged. That's why standards are trusted. Here's the fascinating part. ISO and IEC cannot arrest anyone. They cannot force compliance. Yet, governments adopt them. Companies depend on them. Markets demand them. Why? Because without standards, you cannot export, you cannot certify, you cannot compete. Standards became economic law, not legal law. In power systems, mistakes are unforgiving. One wrong protection setting, one communication failure. And entire cities go dark. That's why standards like IEC 66185, IEC 60255, IEEE grid standards are not optional. They allow interoperability, grid stability, smart and automated networks. Standards turn power systems from fragile machines into resilient systems. Today, standards are no longer just electrical. They define data exchange, cybersecurity, automation, artificial intelligence. A modern power grid is as much software as it is hardware, and standards are the bridge between them. International standards are invisible. You don't see them. You don't touch them. But without them, electricity fails, planes fall, internet collapses. They are not limitations. They are freedom through order. And the story isn't finished, because the next chapter is being written right now. Thanks for watching. Stay safe and stay curious.